That's just ridiculous. That's an opinion. You can have it, but I mean, I think that's ridiculous. That's my opinion. He just goes, I wish I could do more like him, and I would say stupid stuff like, I wouldn't represent flat earth as well as other people do or as bad as other people do. I would just represent it in the way that I am because I'm just a man. That's what he does. He's devoted a lot of his life to speaking the truth to people more than what you'll ever know, because all you know is what you see on YouTube, and he has a lot more than that. He's invested a lot. He does a lot, and I don't, like I said, I don't know him that well. I mean, his personal life, I don't know at all.
When you say he invested a lot, what is the example that makes you say that?
What do you mean? He gave up his living to push a flat Earth theory and figured out a way that he can make money off of it with his app, and he's pushed that. He's invested a lot in that. He goes on talk shows, almost a daily event, which takes a lot of time and effort. He's invested in the equipment to do that. He takes away time from his family and friends to do things like that, and he thinks he's doing for a good cause, right? Spreading truth. He's now moved from an atheist theoretical view of his worldview, religious wise, believing in no God, to knowing that there must be a creator, which he sees how people cause that God. I mean, he's like, in the last 6 years have done all that. That's more than what I can say about myself.
Yeah, and he's coming from maybe one of the weaker positions for flat Earth, right? If you're not going to be claiming a particular model and then using all the aspects of it to defeat your opponent, I think that's going to be a problem for whoever's wanting to help the individual. For instance,
He literally I'm sorry, but in the debate with Professor Dave, he like handed the victory over. Like it should have been so much better for the flat Earth argument, and he represented the argument horribly. He made the globe look amazing against Professor Dave, and Professor Dave is not a professor. Like that should have went very differently, but
yes,
I don't know. It's like he purposely took a step back from being assertive, from being like really just concrete with an argument at the time that it was most important to have a concrete argument.
Yes, and if he was going to do it again and I had the opportunity to coach him, I would bring up exactly what we were talking about 10 minutes ago, Shiny, and I would use that definitely. So to plant some seeds of doubt in their own mind, those guys, that they could be under mind control, ignoring all their God-given senses, ignoring all the red flags.
Did he rage quit after running interference? Like I had to go in a store and grab a filter.
Yeah, Rakeel left. Yeah, the beautiful thing, in my opinion, Shiny Money and Noah, is that if you take the biblical flat Earth position, you have all the ammo. All of the ammo. But some people just aren't using it.
Well, okay, so both my parents are O negative, I think. So does that mean I have electronic superpowers and the ability to read the future?
Well, you definitely have that power as a believer in God to know what's happening in the future. And probably, right? You can lay hands on people and heal them. Oh, go ahead.
Sorry. There's like in like sound, in the science of like acoustic waves. There's this thing that they call like noise cancellation, where when the waves are it's like two sounds, right? But because they're like overlaid, the result is no sound. So it's like noise cancellation. And I think that, if everything really is like a wave function, the same thing can happen for electromagnetism. Like if your body is actually creating a bioelectric field, you could like have like that effective noise cancellation, I think, for electronics. Like, I don't see why not. As long as your body is like doing the right thing.
Absolutely, Shiny. So imagine if people have a weak, very weak bioelectric field, and some people have a very strong bioelectric field. I don't think everyone has equally the same amount. Perhaps that's just my theory, but I could be wrong. Maybe let's say someone on their deathbed, dying, I don't think their bioelectric field is as powerful as someone who, feels very strong.
Yeah, if you really like pray and meditate and just, hey, what's up, NASA show? Yo, you think Earth is a ball?
Alec, is that you?
Best laugh on the globe side.
Alec, is that you? You got a new name.
Hey, what's up, NASA? Yeah, it's me, bro.
I haven't seen you in a long time. How you been? You?
Are you trying to make
Yeah, no, I'm
Jesse? Are you trying to make friends with this guy?
No, I
me
said I'm
and NASA
surprised
are
to hear
cool,
about
man.
Alec.
We talk to each other
It's
in
been a
DM.
while it's been a while since I heard from him. I'm actually surprised he's back because it's just a different name.
I find his personality repulsive, honestly.
Okay. I mean, facts are a tough thing. I know.
I mean, dude, he's top 5 Globers in my book. This dude really makes this fun.
I got
Yeah.
Bacon at number 1 for my. People
I was
put
supposed
Ruhif
to.
at number 1, but I think Bacon's a little better than Ruhif.
I like Ruhif. What happened to Ruhif? He has been around for a while.
Bacon's from Brazil.
Yeah, but what are your qualifications for top Glober? Is it just making good Glober arguments or making good listening
Yeah,
material?
both, I guess, but mostly arguments. I mean, Bacon probably debates, like makes kind of some of the best arguments. Problem is, he's kind of a quiet, reserved guy in a place where people just, go crazy and talk over each other. And trust me, I'm guilty of it. I'm not saying it's other people than me, but like a guy like that doesn't do as well in Discord.
Bacon is good listening material because he actually makes flat Earth arguments.
Like what?
Well, that's why he's the best Glober. Because
Like what?
well, he just knows that celestial navigation is pretending you're on a ball, and he makes
Celestial
sure that you know his
navigation.
position about that.
Celestial navigation requires that you be on the ball. That's correct. It will not work on a flat Earth.
Yeah, the method that you're using is like you invoke spherical
You have a method?
geometry to the surface. So no matter
You have a
what
flat.
surface you'd be standing on, even if you knew the shape of it, you'd have to pretend you were on a ball.
So you have a flat Earth celestial navigation method? Can you do a simple 3-star fix
Yeah,
for
dude, you could just use
$10,000?
an astrolabe.
Yeah, but that. So I mean, there was $10,000 out there to solve a simple 3-star fix. Why didn't you do that according to flat Earth?
Because McToon's whole thing is set up so you would have to appeal to the ball model to get the
Incorrect.
test done.
Incorrect. He gave you a simple 3-star fix.
No, it's when you just say it's a 3-star fix. His challenge requires that you like pick locations that are like depicted on the ball.
He had a 3-star fix taken from a position, and you have to.
Yeah, but you don't understand, dude. He's making sure that the correction, like he's referencing the ball model to tell you whether or not you've done the fix correctly. Like he's already presuming that the ball is correct.
Incorrect. You just had to come up with the position he was at when the 3-star fix was done.
Brad.
And you had
But
to
you
use flat
literally
Earth.
have
Yeah,
to
but it doesn't allow you to use Google or any of the maps because they're all supposed to be globe maps.
Correct. Yeah. Google maps are
Yeah, he's like, oh, prove
projection of
Earth
the
is
globe.
flat by getting a globe map and finding the angles to stars on your globe map. It doesn't make
Well, no,
sense. The
see,
challenge is stupid.
what happened was there was a 3-star fix with angles to 3 stars. He gave you the time, he gave you the angles to the stars, and you had to calculate where you were. Now, if you
He
do
wants
that,
you
Yeah,
to
but you
use a
need
globe.
You need the
He wants you
distance
to
to
use
the
a
mountain and the star and everything to make that calculation in the first place.
No.
So what
No.
McToon really wants is to get out, measure that link to that position, and then make all the calculations. He wants us to do all the work all over. That's fucking madness because it is just flat Earth map positions because it's an azimuthal plane, which means it's horizontal where all your
Exactly.
points are
Do the
fixed at.
three-star fix.
Exactly.
Then do the
Yep.
3-star fix. Then do
Dude,
the
to do a
3-star.
3-star fix, you're gonna have to reference a globe map right now. Okay, if you really want me to make a map that's like thousands of miles, like you gotta let me go to these places, but they don't let you.
I don't understand what that's got to do with the 3-star fix.
Any map that I would reference has been bent around a ball.
Okay.
Yeah, McToon is forcing you to reference a ball. It's like
Oh, he's
that's
not.
not even a real doubt.
He's just telling you to solve it using flat Earth technology, flat Earth techniques, and nobody can do it.
Yeah, for that we need our azimuthal plane, the horizontal plane, which is a flat horizontal baseline.
Then do it. Nobody can do it.
The problem is,
You
people
guys can't even understand the circles I put on in a 360-degree full circle, and it shows clearly that you're only using 1/6 of the full 360 circle from the inside out.
I have no idea what you're talking about when you say that.
you're
Anyway,
pretending you're on a ball.
He had a 3-star fix, and several people tried to solve it, but nobody did. No one won. It's selection navigation.
Yeah, but when you're using a radius, NASA, you're using the map of a circle. You're using the formula 360 over 2 pi radian.
What's that got to do with anything? Again, that's.
You're pretending you're on a ball.
I don't know.
That's what it is.
Pretending you're on a ball. We just take a 3-star fix and use
In spherical geometry, no matter when you change your position, it is confined to the surface of a sphere. You pretend that's happening in the method that you're
Well, no,
using.
again,
Right?
if you
You say,
no,
every
the
time I take a step, I'm moving along the surface of a sphere. No matter
the
what your
argument-
shape of what you're
argument
standing on is, when you do
the
this method,
argument
you're going to
is-
pretend the ground is a ball, even when it's not.
Your argument is that selection navigation shows the Earth to be flat, yet you cannot solve a simple 3-star fix.
I already know for a fact that Bacon did the challenge with a flat map, so McToon didn't accept it because he said something so
Bacon did the
stupid.
map using Bacon did the map
That's
using
Bacon himself.
Bacon.
Bacon literally did the challenge, presented it to McToon. He did it with a flat map. It was like a stereographic projection. I can show you the map they use.
Show me.
All right, one second. But yeah, Bacon went to go get that $10,000, did the challenge, presented it to McToon, and he made an excuse.
Oh, that's a globe projection. That's an AE projection of the globe. Yeah,
It's a flat map.
it's an AE projection of the globe.
It's a flat map, but what's
AE projection
distorted
of the globe.
from the globe is the proportion of the space between the longitude lines. It just maintains the proportion if it were as if
So the longitude lines get
you
further
weren't
apart.
on a ball.
Well, but that only
But-
covers like down. That only covers down to like Australia. Why'd you cut it off?
But he literally did it, dude. His circles of equal altitude, they weren't circles. They were like ovals of equal altitude. And he was able to do a 3-star fix. So, you could do whatever you want with that information. You could ask Bacon. Dude, I'm not making this up.
Bacon. In the meantime, though, so why can't anybody else do it? Why can only Bacon do it? I mean, anybody can do.
I'm sure other people can do it. They just act like they don't know what they're doing for some reason.
Well, so see, the thing is, a 3-star fix. Nobody. I don't know about. I'll look into this Bacon thing. I assume that he didn't do it. If he did, if he had like non-circles of equal elevation.
Yeah, no,
that
they
pretty
weren't
much shows-
circles. They were ovals.
Okay, then that pretty much shows that the Earth isn't flat. Then, 'cause-
Yeah, but he found a position where he could, in fact, get within 10 miles his coordinate, with the intersecting ovals.
but
So
then
he was able to do
So
it.
he used that the Earth was a globe and projected it onto a flat map, I suppose.
I'm glad you understand because I think you're a top glober, so I knew you'd understand.
Yeah,
why
so
I
he
said it.
basically used the fact the Earth is a globe and projected the oval, calculated
No,
the circle.
it's literally a flat
and
map.
then-
It's not a globe in
then
this
bent
projection.
It is a globe projection.
It is not a globe in that projection. It is a flat
It is
map.
a globe projection.
Incorrect. What the
What do you
heck,
mean
dude?
incorrect? It says so.
I mean, look at it,
Hold on
dude.
a
That's not a globe. You
Wait,
really think
hold
that's a
on.
ball?
It's a projection of the globe.
It's a map that is flat. The projection is flat.
Projection of the globe on a flat, right?
Oh my
Taken
gosh.
from the ball.
It's just
And
even when you're
visualize-
not looking at a ball, you think you're looking at a ball.
No, that is an AE map projected from the globe. I'm familiar with this.
Johnny, buddy, you know what's interesting? I think flat earthers can produce a world map before the globers can produce a physical model of the globe.
If you took that map and laid it on a ball, you realize how different it would be from the globe map that you think it is, right?
All maps are flat. Like by their nature, they're deep. They're a two-dimensional drawing of the surface.
All maps are flat.
Yep.
It's flat coordinate
Projection
plane.
of the globe. That's correct. The projection of the globe. That's how you
Two-dimensional coordinate plane.
You're not familiar with how maps are projected.
And then you guys say that the coordinate plane, that two-dimensional coordinate plane, is bending due to 3D space because you're doing spherical geometry. That's affirming the consequent. Like you can't just say, "Oh, I'm doing
Affirming
spherical
the
geometry,
consequence.
I'm on a ball."
You take a projection of the globe. You take a projection of the globe and then say that it's not a projection of the globe.
That's not affirming the consequence. That's just a consequent. That's just theory. Anyways, you could
Yeah,
tell
no, there's
what
actually
your,
another fallacy I was thinking of. I couldn't think of it on time.
you can tell if your map, like if you're like, yo, I got the flat map, You can tell if it's flat or not by doing distances. The distances will tell you if it's planar or non-planar. You know what I'm saying? You could do
Half of it
pi
using it.
You could do a circle with a radius with pi. You could do a square with an X in it and check the lengths of that, and that should all. There's like a formula for these things that they're always the same on a planar surface. So if you don't get that, then you know it's not planar. You know what I'm saying? Like if you were to make a circle around something on your map and then do the pi thing, and you see the distance of diameter of the circle, you'd be like, oh, it's this is what it is.
Yeah, the fact they only use pieces of pi shows you that they're only using half of a 360 full circle.
Okay.
That 180 is half of a plane.
Oh Jesus! You never give up on this argument.
Well, dude, you look
No,
at the sky,
NASA, because
right?
with the amount of radians in a circle gives you the amount of that 1 radian angle that you get from the 360 over 2 pi.
No,
When you multiply that by the amount of radians, you get exactly the radius plus pi, because you only have pi, because you're only using the 180, and on that 180 you only have 1 pi.
You're doing a circular reasoning there.
No, it's just basic math from a formula, 360 divided by 2 pi, which equals 57.29, which is an irrational number. That's why you can use that same division of 1, 1, the same arc length, the same radius. You can use that as an angle. That angle can be placed around the center point, and that is a radian circle of certain degrees.
Radian circle makes no idea.
I mean,
Radian
just
circle-
ask how many radians. Crystal, how many radians are in a circle?
How many radians are in a full circle?
Yeah, in a full circle, how many?
2.
There you go. There you go.
2 pi.
2 pi.
Yeah, but that pi is around the center point. That comes before that thing, because that pi is standing for your 180. Because when you have 180 over pi, and you divide that by 180, you're left with 1 pi halfway of your full circle, and you're only using an arc of 90 degrees.
What the fuck did you?
Yeah, so for a full circle, it's 2 pi.
Yeah, but that's because that arc length of that original radian angle with the same angle and the same arc length and the same radius, that fits 2 times around the center point. That is why you're doing it 2 times pi.
No, that's not why you're doing it 2 times pi.
Yes, half circle is 1 pi, full circle is 2 pi.
But that's not why you're doing it pi.
It's like 6.29 or something amount of radians you can have around a whole circle.
No.
Yeah, but
Yeah,
6.28 is 2 pi.
It is.
No, but
hold on,
radians. The radian is about 57. The radian is about 57 degrees. So the circle is 360 degrees, so it's approximately 6 and a little bit.
That's what I said. You said no.
No,
I said it's got 6.
I'm sorry.
I said a circle has 6.28 radians in it.
Okay.
Thereabouts. And you were like, no.
I'm sorry, I misunderstood what you said. I thought you put pi in there. I apologize.
Well, I want it written in blood. So
I think you have to listen to Jeremy. He has RH negative blood, so he has authority over you.
That is the dumbest thing I've heard Witsit say, and it's been a while.
So
Well, if you look at the pictures, I showed you that a 180-degree arc around the center point stretched out because it has 2 90-degree angles, meaning an arc of 90 on one side and an arc on the other side, which makes it a 180, and which gives you a 90 radian circle, because you got 90 radians from you got 90 radians on the radius from center point down to the rim of that circle, because that circle is bigger than 1 degree. You're using a 60-degree circle, NASA.
90 radians is like 90 times 60. It's like I think it's like 11 circles or something.
No, it's 5729 to be exactly.
57. That's a 5,130, and divide that by 360.
No, that's arc minutes. You should be putting that not because
14.
Yeah, that's arc minutes, because arc minutes in navigation equal. You're using a 1:1 ratio.
We're not talking about navigation. We're talking about circles. When did you change the navigation?
Yeah, but we're trying to get the length of your radius of that circle. That's 5729 is what gives you your length in your radius in a straight line from the center point out. Otherwise, you don't have a length.
You understand that any
Oh my God, last night SE didn't know how balls work. Now Crizzle with the circles. What's it going to be next after this? I can't wait. I'm excited, guys.
A circle has 2 pi radians and 360 degrees.
It's
Yeah,
just
but
two
when you're
total
only
lengths.
using 90 degrees, then you have only 2 arcs of 90 on each side, but you still have that 2 pi for the full circle.
No, 2 pi is, oh my god.
I don't know what you're
90 and
saying.
90 is
What are you
180.
trying to
That
say?
would be pi. 90 is pi, what? Pi over 2.
What
Pi
I'm
over 2 is
please can
90.
what I'm trying to
No,
say is that when you divide the 360 by 2 pi, you get the value of 1 radian. That is a
Yes, but that's
length
not how it's
that you can
defined.
use to calculate your radius. Because how
No,
many of those radians are in that length, it tells you how much degrees or how many radians that are in that length.
you don't need to convert to radians to do
And
that, but okay.
arc minutes in navigation equal nautical miles. That's why you can put nautical miles behind that thing, because that 5-7 thing doesn't have a value because it is an
Wow.
irrational number, just as pi.
Oh, wow. You've combined a whole bunch of stuff into one big tar baby of various facts.
No, because when you take that amount of radians and you multiply that by 1 radian and you add the amount of pi because you only used 180 because you have only 2 angles
Jesus,
of
stop it.
90
Please, my
degrees,
head hurts.
making it a full circle. That's why you have
What?
only 1 pi. But when you multiply that and add that 1 pi, you get exactly your radius in arc minutes. When you multiply that by
Going on?
115, 0,
that's
7,
wild.
What the fuck is this?
945, then you get exactly your radius in miles, which is for 60 degrees and
All
not
right,
90.
let's
What
fucking
you
tone it
slow
Settle
down,
down,
dude.
guys.
Nobody, yeah, dude. Like, no one needs to get
Let's all
heated
settle
over
down.
fucking preschool geometry.
Jeremy likes pie like a fat kid loves cake, but you don't hear him
Piezo's here.
bitching.
Hold on, Piezo's here. What's up, Piezo? Do you have something, or are you just listening?
I just joined in and heard people talking about whatever's happening right now about a circle. Save us.
Yeah, but
They're not talking
it's
about
all
anything.
it's not. Did you have some new dope shit, or you just like kicking it?
Okay. Tell us about the ether, please. I don't want to hear about 2 pi for one more second.
Yeah, but the thing you guys are missing, when you have a radius of 90 or a radius of 60, you're using a radius of 60 over a plane of 90.
A radius is a length, and degrees are not lengths.
Yeah, but when you're
radians
measuring
aren't
over the
length
Earth,
either.
the only thing you're measuring is arc minutes, but those arc minutes equal nautical miles.
Oh god. Which has nothing to do with geometry.
I think she's
Yeah,
talking
but you're
about degrees per
calculating
mile in the
length in a
sky.
straight line outwards.
Celestial sphere. I think that's what she was saying.
I have no idea what I gotta stop talking to Chris about this because she's just
Dude, you
Yeah.
know how you know the ether's real? Because capacitors work.
Yeah, capacitors work by electricity. Yes, sir. Ether is the ether electricity?
Yeah, but
Is
it
that Rob?
requires the same plane as you have at height above your
A
head.
one-on-one
And that's
between
the
Rob
point.
and
When you have
Piezo
an
or
axis
something?
of 90 going out, you have an axis of 90 on the plane itself as well.
Hold
That
on,
is what gives you your
Grizzle. I think we're
sphere
moving
in the
away from
first
that.
place.
Yeah, but that's
All
okay.
right,
That's
you
okay,
got him.
Chris. We can do that. We can do that on a globe as well. That's not a problem.
Yeah, ether's not electricity. Ether's the medium that allows for electricity.
Then don't say it is then don't say it's because capacitors work then. Because capacitors is strictly electricity. Thank you very much. Have a nice day.
Oh, that
You too.
guy. Yeah, I don't interact with that guy, whatever his name is.
Yeah, it's okay. I speak
Well,
fast.
all that
That's why
stuff
people
about the pi and the radius, I don't know about that. What I was trying to say is like in celestial navigation, the method, like your observer position is inside of a ball. You're at the center. You're at the center of a ball. And the sky is like you're 180 degrees. That's half of your circle, no matter where you are. So when
Yeah.
you look at the
We're off that.
horizon, where the star intersects the horizon, like that has to be 4,000 miles below your feet. That's that radius curving down. You know, so if you're standing at the
Rico.
North Pole,
Hold
or I'm
on.
sorry, if you're standing on the equator and you're looking at Polaris, you
Oh my
know, where
goodness.
the ground intersects the sky, that's 4,000 miles below your in your
All
model.
right, great. We're off
Yeah.
the circle thing. We're on to the ether thing with capacitors. All right, guys.
Yeah,
Jesus
the
Christ.
dope head wants to change topic, but nobody cares what the dope head wants.
Dude, nobody cares
Yeah,
about
but
how fucking second grade geometry works, dude. I learned that
okay,
fucking 20 years ago
Yeah,
No, no,
when
no.
I was
you
fucking
should
learning how to
care
walk.
because it gives you more links in the circumference of your Earths. That's why you should care.
I gotta
Yeah,
just
yeah,
start
yeah.
muting
But
people.
All right,
Maybe
so
I don't know. I don't
the
even know.
ether and capacitors. Can someone explain why a capacitor doesn't work without ether or not?
yeah,
Dude, you
yeah,
don't know
for
how
sure,
ether
bro.
works, bro? Everybody knows how that shit works already, man. Come on.
well, yeah, yeah. You're begging
Nah,
the
bro, you
question.
don't even know how a circle and radians work. So like, let's just let the big boys discuss ether.
Okay,
No,
well,
these
you're
guys
begging
actually don't know how cell nav works, though. That's the funny thing.
you're begging the
Ether's easy to
question.
grasp, dude. It's literally right there, you know. But the cell nav thing, these guys pretend they don't see it. It's weird.
Dude, so the reason that you need ether for a capacitor to work is because a capacitor by definition is an open circuit. It's two pieces of metal that are not touching. And yet there's current that flows between them. But current is defined by the flow of charges, electrons, right? Except electrons travel through a wire. If you have a capacitor in a vacuum in the gap, and it's a vacuum gap capacitor, how do you have current flowing? Because by Kirchhoff's laws, if I just create a simple loop, a closed circuit, a series circuit, but it's got a source, a voltage source on one side and a capacitor on the other, technically that is an open circuit, physically speaking. Yet as soon as you connect it to that voltage source, it will conduct current across the gap, and the current in the gap will be equal to the current in the wires. Based on that's what Kirchhoff's laws dictate. So there will always be the same current in the wire as there is in the gap between the plates. How is current traveling between two plates that are not touching? Well, it's the ether. What current is actually doing is those charges when you attach that voltage source. What voltage is it's pressure. So you can use the analogy of like water in a pipe. But that voltage creates pressure in the wire, right? It travels down the wire all the way to the plate. When it reaches the two plates, right, you have an area in between where the ether is bounded between those two metal surfaces. It's able to propagate that influence across the gap because technically what's happening in both the wire and in the gap is the pressure itself is being transmitted through the ether, and the ether is present in the wire and the ether is present in the gap just the same. So in the wire where there are electrons in the metal, electrons or metals have the unique property of having free electrons, a free electron sea in metal bodies. The ether in there, when it pressurizes, it pushes the charges. Well, the ether in between the gaps of the two plates, it still feels that pressure front. That pressure front travels across the gap from one plate to the next. And when it reaches the second gap, that pressure hits the second plate and begins pushing charges out the other side.
Wow, you don't understand electronics at all, do you?
All right,
That's
So
very
so
how
clever.
you've made your grandstand. Now, could you actually supply a rebuttal to what he said, please? Thank.
Well, what happens with a capacitor is the electrons are the negative charge, and they build up on one plate of the capacitor, and the other
Correct so
plate
far.
gets the holes, basically. The missing electrons are on the other side of the plate.
Wait, how
Okay.
does that work? No,
Well,
no, there's not
all
holes
the
on the other side.
yeah, there are.
Holes come from a
There,
deficit
there,
of
there's
electrons.
there's locations in the atoms that don't have electrons to satisfy the electron uh, wants to be balanced, basically. Not that it wants to; it doesn't have a mind, but it naturally wants to be balanced, and it wants the negative charge to come over to it. But the problem is the capacitor. Usually, they make them with a piece of non-conductive material between them. There's not a gap there. There's no gap in between the two.
Aren't you
What do you mean
describing?
there's no gap in a
You
capacitor,
can't make a
bro?
capacitor with
You're
a gap.
literally taking the example I gave you, completely changing all the details, and then attacking the version that you created that I have nothing to do with.
That's
That is
but that's
definitionally a straw man.
how capacitors actually work, though. You're describing a capacitor that doesn't
So
exist.
you're telling me, hold on, wait, just for this recorded space to hear, are you asserting that capacitors that are based of two pieces of metal in a gap don't work?
Well,
No,
they
they
need
do, but
electrolyte.
most capacitors nowadays don't have a gap between them. We put a
So you've never heard of
non-conductor.
a vacuum capacitor before?
No, there are
Yeah, I mean,
capacitors that have gaps.
there's
Yes, I
glass
agree.
Okay,
capacitors.
so it
Any
sounded like I
any
heard you
clear
say that
liquid.
with a gap
I
it
don't
wouldn't
know.
work.
But
Am I able to get in
but
here at all?
the electrons aren't moving across the gap.
Okay, so we're agreeing partially. I agree. Electrons build up on one plate, the one connected to the plus side of the voltage source. But the other plate, which you can hook directly into ground, you can literally just use a voltage source on one plate and a ground on the other, straight into Earth. There are no holes. Like the other side, the
The
side
holes
connected
are
to Earth it's electrically neutral. It doesn't have a
Bro,
plus or minus.
why are
Neutral.
you claiming
And then
electrons though, dude?
hold on. It's electrically neutral on the side connected to ground. The side that you hook the voltage source to, as soon as you close the switch and it feels the voltage source, it will begin conducting current from the voltage source side to the ground side and flowing directly into ground. Now, where does that current come from?
no, it's the movement of the holes is the current.
There's no holes. We just discussed it's neutral before you close the switch.
No, what happens is the ground has atoms that have holes and atoms that don't have holes. Okay, the
What do
ones
you
that
mean the
have
ground has
holes, so to speak, the ones that
electrically
are
neutral?
missing electrons.
You're literally
Are
making up stuff, bro. You have zero idea
no,
what you're
no.
talking about. You're mixing
It's,
domain. You're sitting here trying to bring in like transistor theory and p-n junction theory into two pieces of metal that are electrically neutral.
yeah, well, they start off neutral before you put the battery on them. I grant you
Okay.
that.
Okay.
Okay,
Perfect. So let's start
and
there.
then one side, once the battery's hooked up, whichever side is the negative side of the battery, gets a bunch of electrons.
But positive side by
Right.
conventional current
So
topology
what's the other side get? The other side gets
is ground.
as well, but the other side gets an area that has no electrons or less electrons, right? That's the positive side,
Yeah. So
right?
you're beginning. The question that you're
That's
asking
what
is
I'm
the perfect
calling the
question
holes.
because
That's what I'm
no,
calling
no,
the
no,
holes.
no. See, you're asking the right question and you're jumping to the wrong conclusion. Your conclusion doesn't make sense. Okay, here, look. The two pieces of metal are not touching. They do not have any direct influence upon one another. They're electrically neutral. Do we agree so far? Do we agree so far?
Wait a second. Yes, I agree. They have an
Okay.
influence in the electromagnetic field, but not the electrons aren't doing anything,
Okay.
other than
Okay.
being on the one
So
plate and not on the other
okay, so we
plate.
got the plate that's hooked to a switch that's open, and the other side's got a voltage source, and then we've got the other plate that's grounded. Both of these plates are electrically neutral right now. Now I close the switch. Bang. Immediately, we see current flowing throughout the circuit, all the way from the voltage source to ground. Now, that instantaneous moment, time t equals 0, when the switch closes, that is when that starts. So at that exact moment, if one infinitesimally small moment of time before that, they were electrically neutral, then what happened that very next instant? You're telling me that electrons appeared on the voltage source side and holes appeared on the ground side? Where did the holes come from? Holes come from a lack of electrons, a deficit
Right.
of
That's the
electrons.
lack of electrons is the holes. I'm
So
referring to them
how
as
did
the
it lose
holes.
its electrons? Why did it lose its electrons? Where'd they go?
Well, the electrons that were in it moved from the one side of the circuit to the side that has the electrons.
Wait. You're
It
saying that the
traveled through the
electrons
battery the
crossed
other
the
way.
gap? Are you saying the
No,
electrons
they
crossed
went
the
through the
gap?
battery. Wait a minute.
No, the battery's not connected to the other plate, dude. It's only connected to one. The battery is grounded at a big metal block 100 miles away, and my capacitors are grounded straight into earth ground.
I have somebody to talk to in the real world. Wait one moment.
This guy always act like this.
I was trying to squeeze in between you guys when he was talking about capacitors, because I mean, technically, any clear liquid is a capacitor. Do you understand that, Piezo?
All materials have capacitance, but in
Right,
terms
but
of a capacitor,
storage.
in terms of a capacitor, you need two bounded metal surfaces in order to create the conductive path that creates the boundary condition for energy storage in between.
Is there an electrolyte involved?
No, it's a vacuum capacitor.
Well, in the one I'm talking about, possibly, yeah. You guys ever heard of the Leyden jar experiment? It's well observed that the electrical charge is stored in the clear medium, the liquid,
Yeah,
not in the
yeah,
rod
it's stored.
itself.
Yeah, it's stored in the glass jar. You don't need a liquid in a Leyden jar. It gets stored in the glass.
Yeah, it's
Well,
stored in the
like I
glass,
said,
not what's in the jar.
anything clear, whether it be a mineral oil,
It
glass,
doesn't have to be clear, bro. It can be
these
any.
are all
Clear.
capacitors.
Clear is an extra step that somebody added. It's not required to be clear. But
Okay, but it's well observed in the Leyden jar experiment. It's actually stored in the liquid medium, not necessarily in the rod or the glass jar itself, but in the liquid medium.
no. You can do a Leyden jar experiment where you put metal plates on both sides of the glass and charge the glass itself. Take the plates away, pass the glass around, touch both metal plates, then put the metal plates back inside the jar, and it'll discharge again.
Right. The glass will hold the electrons. Yes. You don't need a medium in the glass jar. Doesn't have to be any
Well,
liquid in the
actually,
glass jar.
Yeah, you
the
actually
glass
do. It
jar
could be
doesn't
air.
hold
It
the
could even
electrons
be air.
either because you can rub the glass jar and touch it, and it doesn't discharge on you. It's actually stored in the it's by the electric configuration of the lattice of the jar, right? It actually causes it gets polarized, so it polarizes the atomic lattice, and that polarization causes it like a voltage potential to build up throughout the lattice, and that's what gets
All I'm
discharged.
saying is transparent mediums, dude, act like capacitors, bro. So yeah, you're right. You could remove the liquid medium, but you'd still
You
have
can
the air. But if you put
you
a
can
if you put a vacuum on that jar, you're not going to have that same effect going on with the storage of electrons as you claim.
well,
The,
they originally noticed this when they were rubbing amber with fur. I guess the amber robbed electrons from the fur, and that charged
Yep.
the amber stone. So it's not, you're
back in the
doing
old
the
days,
same
yeah.
thing with the glass jar. You can take a piece of fur and wipe it in
We're
the same
getting away from
direction
the
on the
topic,
glass
though.
jar.
We're getting away from the topic. Where did the electrons go? Because I said at time t equals 0, you close the switch. One instant before that, both plates are electrically neutral. The very next instant, when the switch closes, one side has a buildup of excess electrons. The other side, you said, now has holes. So if it has holes,
What's the other
where
side
did
of
the
your
electrons
battery
suddenly
attached
go?
to? What's the other side of your battery attached to?
My other side of my battery is grounded to some foreign object ground far away. It's nowhere part of the system.
Right. So what's happening is it's traveling through the ground back to the negatively charged. It travels through the battery.
No, the battery's not hooked up to the second plate, dude. What are you not getting about that?
The battery doesn't have to be, but it's hooked to ground, and the other side of the capacitor is hooked to ground. So
Okay,
it's
so
completing
the
a circuit
battery's ground,
through the ground.
the battery's ground is not the
It's
same
using the
ground
ground
as
as a
my other
wire.
plate. Dude, you're not listening. You're just talking to hear yourself talk. You're not listening. The battery is not grounded to earth ground. The battery is grounded to some block of metal floating in the air somewhere on the other side of the earth by a big long wire. Okay? My other plate is grounded to earth ground. Okay? How
You're
does
saying the battery's not touching
conduct?
any part of the earth.
No.
Floating in the air is not grounded.
Yeah, you can have floating grounds, bro. You can draw ground from metal objects.
Right, and the metal object's attached to what?
It's electrically insulated. It's floating in the air, bro. It's not grounded. Like you acting as if it's
What's holding the metal rod up? What's Is it touching the ground somewhere?
No, it's not. It's held up by an
grounded.
electrically insulated. It's held up by an electrically insulated glass cable or rubber cable.
Well, then it's not grounded.
Okay, yeah, that's what you call a floating ground. It's not grounded to earth ground. No, it's not. But
Floating ground.
But just like on a car, anybody who knows anything about working on cars, you can ground to your chassis. It works, trust me.
Yes, because your
Right.
battery is attached to your chassis. The ground
Yeah,
post of your battery
I have a
would be
big
that
three.
you
I've grounded my battery to my chassis.
You disconnect the ground post to your battery from your chassis, and you no longer have a ground on that chassis.
Okay, that's not what we're talking about. So what's the point in saying that's a complete non sequitur? You're wasting all of our time. Why are you trying to change my illustration? I'm giving an example.
If
You're
you
changing it.
disconnect
It doesn't make sense.
the positive
I think
of
you're
the
talking
battery,
just to hear yourself talk.
You
in your
have,
circuit,
listen, it's very simple. It's very simple. The ground that the battery is connected to is completely isolated from earth ground. There are two separate grounds. Okay?
It's not
So,
grounded.
so the other plate is earth grounded. The first plate's cooked to the battery, and the battery is grounded somewhere else, completely insulated, isolated from earth ground. So how does the current cross the gap
circuit wouldn't
in the
work.
capacitor?
Circuit wouldn't work.
Yes, it does. Bro, yeah, have you lost your mind, dude? You're saying it has to be hooked to earth ground to work? It does not have to have a common
You
ground.
have to create a complete circuit. You don't have a
Any
complete
ground
circuit.
has to either be hooked to earth ground or the ground where it came from. That's the only
No,
two
it
places.
doesn't.
There is no way to have a ground that floats in the air that is not connected to the ground. Just like what I was saying, you said you could ground to your chassis, but your chassis won't have a ground if it's not connected to your battery. You disconnect your battery from your chassis.
Hey, Cole, how do you think
no longer
electrical
has a
systems on
ground.
airplanes work, Cole? If
cannot
what you're saying is
have
accurate,
a ground
airplane electrical
because they
systems
got
wouldn't work.
batteries. They're grounded back to their batteries. That's what I keep saying.
Okay.
If you don't just have a
It's
floating
just a
piece
closed.
of
You're just
metal,
talking about a closed loop system.
you cannot have
And
a
it's the
floating
negative.
ground.
It's the negative pull of the battery that's connected to the chassis, not the positive.
You cannot
So the
have
negative
a
is where the
floating
electrons
ground.
are from. The negative is where all the electrons are at. The holes are on the other side, where the positive's at.
So how does current cross a gap? You still haven't answered the basic original
It
question.
doesn't cross the gap.
It does cross the gap. There's current in the gap. I can take a magnetometer and put it in the gap and measure it.
No, capacitors don't work by the current going across the gap. The magnetic
Current
field goes
does
across
cross
the
the
gap.
gap. You
but
are
the-
wrong.
no,
You are wrong. The current in the gap has to be the same as the current in the wires at all times. That's Kirchhoff's laws.
Yeah, the magnetic field crosses the gap, not the.
It is current crossing the gap. You can measure it.
You're measuring the current. You're measuring the electromagnetic field crossing the gap. What you're doing?
Oh my gosh. Just Google displacement current and then educate yourself and then return to this conversation later.
Sorry. Thank you. Okay.
Anyways, the answer, once again, is that you have a pressure front traveling through the ether medium. That pressure front, when it is inside of a wire, is able to influence the electrons in the wire and move them and create what is called conventional current. When that pressure front travels between metal plates in a region where there are no electrons flowing, but you still have the influence of that pressure front traveling. So when that pressure front bridges the gap to the other plate, it continues pushing and influencing the electrons on the other side. And as long as there's a continuous path of that same stream of ether being that's flowing through the circuit, you will continue to have current flowing through your capacitor.
Can you remove the ether from the equation at all?
I mean, if you remove the ether, then you now have to answer what's the physical cause of the current in the gap. By what means is it manifest and it propagates?
The electromagnetic field.
What's that field made of? What's a field? Can you define it for me?
The field's just a field. It's part of nature.
A field. What's its substance? What's its essence?
And it's part of nature. We got about, what is it, 6 or 7 different fields in nature? They're what convey the, you got the electromagnetic conveys what electrons are doing and what photons are doing.
So tell me, what is the ontological status of this field you speak of?
I don't know. You're going to have to ask a physicist what it is, because I don't think it's an
No,
actual
it's
thing.
not considered to be physically real. It's a math
Yo, wait,
object.
wait.
Field,
Can I just
No,
say
no, it's a
something?
real thing.
construct.
Can I?
It's a real
Yo,
thing.
wait. Yo, shut up. Shut up. Shut up. An electron, like, increases the field around it. An electric field is not where electrons travel. It's emanated by an electron.
Yeah, so the electromagnetic field that you speak of, and all fields, all fields, electric, magnetic, electromagnetic, all of them, they are defined as mathematical abstractions which describe the forces that are measured in a region of space. So an electric field describes the electric forces measured in a region of space. That's the definition of a field. That is not an ontological definition. That does not tell me what a field is. That tells me how a field is measured. It doesn't say anything about what it is. That's like me asking you, what is a horse? And you say, oh, if you put a saddle on it, you can ride it and it'll go 40 miles an hour at top speed. And I'll say, okay, that's what a horse does. I want to know, what is a horse? I'm asking you, what is a field? See, you can't give me an answer that's anything physically real, because that would be a medium. When I say the ether, I'm talking about something that's physically in corporeal physical existence in this physical world. It physically exists, right? It's able to physically influence bodies and act upon them with forces and energy because it is physically substantive. When you say a field, you're saying a math object that only exists as a bunch of numbers written on a piece of paper. You can describe for me all day in terms of Teslas and Gauss and Coulombs and whatever other units you want to use in your descriptors, the values of these field values at locations in space, but you're not telling me anything physical about what it is or what is doing this thing, what is creating these forces, what is that mechanism of action, right? What is the physical interaction of one thing upon another, the mechanism by which this force is being applied? You'll never be able to do that until you point me to something physical. Because we live in a physical world. People just like swallow hook, line, and sinker this crazy indoctrination of this scientism religion where they're told there can't be an ether because we tried to measure Earth moving and it didn't work. So that means instead of saying Earth doesn't move, it means there's no ether. But then you just have to come up with all this nonsense about, oh, non-physicality is everywhere. And the entire universe, every square centimeter of the universe from end to end is filled with complete non-physicality, and that total non-physicality gives rise to everything that's real. And we'll call them virtual fields and virtual particles and virtual photons. And we'll just layer them on top of the real physical world that we actually observe and say that they're just overlaid on top of everything, but they're not there for real. It's nonsense. Every year, the mainstream becomes more open and more welcoming of physical medium theories, fluid vacuum theories, ether theories, etc. More papers are published and more studies are done in more prestigious journals and laboratories in different countries every year than ever before. Right now, there's huge movements being made in analog gravity theory and superfluid vacuum theory within academia, not just in the United States, but other places especially, because they have such a satanic stranglehold on academia here. But that are making leaps and bounds in terms of these theories, and they produce mathematical solutions that are at least identically satisfactory, and in some cases more satisfactory than the current field theories that are used in the standard model of physics. Yet
Yes,
they
people
provide an
Where are the
intuitive
papers?
physical explanations for what's going on instead of saying
Yeah,
everything
show
is
me
just
the papers.
abstract.
Show me the
What is
papers.
analog gravity? never heard that before.
Superfluid vacuum theory. Look it up. I mean, it's right there on Wikipedia.
Oh,
You say
I need to look
I'm
up
not
here.
arguing with you.
You
I'm
assert
just trying
something,
to
and then I need
explain it.
to show it. Right, got it.
No, this is true. Actually, there's people I've listened to modern day physicists that are young and professors. They literally have to go to conferences that are outside of the paradigm because one, they're frustrated.
It's cutting edge, bro.
Yeah, absolutely, it is cutting edge,
But
and
the
they have to
papers
go
are
to
in
these
peer
outside
reviewed journals, bro.
conferences.
It's not like I'm
So is
making this
dark
up.
matter. So is dark matter. You guys reject that one.
Something that's never been observed, right? Yeah. I wonder
along
why.
with analog gravity and field theory and other bullshit.
Oh, actually, no. They've done experiments in laboratories to support these ideas.
No one's ever done an experiment to show dark gravity is real.
Yeah. Papers, please.
Dark matter or dark energy, whatever.
Dude, you say papers, please, as if you don't have a keyboard and a screen and Google in front of you, and you can find it faster than I can.
So you can assert something, and I have to go look for it. Got it.
Yeah. If I assert F equals ma, are you going to require me to go find Newton's original paper?
No, stop being absurd, dude. Stop being so pedantic.
F equals ma is well established in the physics world. This analog gravity stuff is.
Well, what I'm saying is well established as well. Just because you don't accept it doesn't change that. Go look it up. Stop being lazy.
Oh, I need to look up. You're going to assert something and say it's true, and I need to look it up.
Yeah, I can assert it. Go debunk me then.
Oh, it's up to me to debunk you, not for you to. It's up for me to debunk you rather than you.
I just told you Wikipedia. You're going to say unless I provide you a copy paste link, I'm not doing my job now. You know what Wikipedia is?
Wikipedia. That's well known as the the epitome.
Yeah. So if you go to Wikipedia, there's a whole list of references. You know how to click those? You know how to use your mouse? Left click. Yeah.
So I need
to.
Okay,
Cool.
I need to debunk what you say. That's logical fallacy.
All I said was there's a
superfluid vacuum theory that provides explanations. Very broad claim. For you to say that I'm wrong, that must mean that there is no such thing as superfluid vacuum theory. Otherwise, what the frick are you talking about?
I ask you for the paper, and you say no. It's up to you. Go prove it. You debunk me. I can say something, and you have to prove me wrong.
So my claim was there's a theory known as superfluid vacuum theory. So if you have a problem with that claim, that must mean you think that there's not a theory called superfluid vacuum theory, right?
Just for the record, guys.
You can assert it anytime you want, and then debunk me.
Just for the record, Just for the record, I posted something on it, and so did Gleam. So have a look there, NASA.
Oh,
so you and Gleam are white knighting for him. Got it. Thank you.
Look at you, dude. Like, you're so dishonest, bro.
Why
Stop with
are
your
y'all
Jewish
taking
behavior.
the bait from this troll?
Stop with your synagogue of Satan behavior, dude.
You're gonna look
Living up
at
to your
it.
heritage.
Synagogue behavior?
Synagogue of Satan, bro.
Synagogue of Satan.
Synagogue of
Now
Satan.
about Payne
Because
Steel.
you can say something, and I say, yeah, show me, and you say, no, go
Can
show
we
you.
get back to the topic, please?
I know the white knights. I know the white knights. Yeah, the white knights are here. I understand.
If you were honestly looking for truth, you would have said, thank you for sharing that with me since it's what I asked for.
He's
Instead,
not honest.
You complained that someone provided you with what you asked for. That is literally a faggot
It's
behavior.
all right, dude. I muted him. Don't worry about it. He's not an honest interlocutor, but let's not waste our time with that.
Yeah, can you get back to what you were saying? Because you let Payne Shield take you off track so much where you haven't said a word about what you were talking about. You've said Payne Shield 100 times. He's a known lying troll. Let's move back to the topic. Very interesting. By the way, shout out to Rakia for bringing up superfluid like 5 years ago. This is a mainstream way of explaining the math they need. The variations in how we see, like our observations would be all different. This is known scientific studies now where all the helium goes, how it would happen. They can recreate it in a lab at variants, like not as well as I think nature does right now, but it's a new, as far as science, it's new, like within the 10 years. But the theory is older, right? They're just starting to be able to understand and how to replicate things that have to do with superfluid and super solid, which I believe is part to do with what they used to call ether, right? It's the medium, or at least the background of what is in space, basically, what they call space.
The theory, the basics of the theory are this: the universe is filled with a superfluid medium, possibly a Bose-Einstein condensate, and that superfluid medium pervades all of space and is what gives rise to bosons and fermions and all the forces of nature.
And things we don't know about because it's unknown physics.
Well, if you look at it, they use fluid dynamics equations in order to replicate all the fundamental forces and fields that we know of today in this theory. The mathematical framework is borne out well. It's
to be
just,
honest, what I've looked into it as far as that, it works out pretty well, like almost to the T, right, mathematically, but it's not perfect. They're still working on what affects it, how it affects everything around it. But the observational part is getting well known. Like they're writing paper after paper about how this background could affect depth perception, sizes and shapes and things like that. Like it's incredible.
analog
Everything we've
gravity.
been talking about, this has an explanation of maybe how it works, right? Which is how science is, right? That's how science starts.
Analog gravity is adjacent to it because they've done fluid experiments in the lab where they're able to create an event horizon within the fluid bath, which basically, as long as the motion exceeds the wave speed or whatever, it'll like the wavefront will never be able to escape its own wake, which is like analogous to a black hole in their theory. Now, I don't believe in black holes, but it's like the same thing. How the because its motion is capped off by the wave speed, then it gets trapped inside basically this little bubble where it can never the wavefront gets trapped inside of like a boundary region where it can never go faster than that, so it'll never be able to escape and be perceived from outside of that boundary region.
Thank you.
So
That's
they're
all I
even
wanted
providing
to know.
explanations for gravity.
I just wanted to know what it was. Is all. I wasn't arguing with you.
No, you were arguing. We heard you.
But I'm home now, so I'm gonna go love on my wife. You guys have a good rest of the day and stuff.
You too, brother.
Yes, sir.
They take it one step further and start talking about super solids, which they don't mention the firmament along with it. But I believe every time they tell the truth, right, there's truth and lies and everything. They might hide a few things or not agree with the, certain worldviews. But with my worldview, it totally explains how there could be a structure above us called the super solid, which would hold in a fluid but let other things in and out, which is basically what my religious belief, right, my worldview on that describes. And if Peyton Ask the Shield doesn't want to go research what a super solid is, who cares?
You're right,
Yeah,
Dave.
only it
I
takes
don't know
25
why we
bar
give the time of day.
to make
Sorry,
it.
Chris.
It takes 25 bar to turn a superfluid back into a solid, which we don't have up there.
When you don't look at it, and when you look at it, it collapses into a particle. That's all nonsense, right? We're supposed to believe, like even Einstein thought that was nonsense. He said, "Wait a minute, are you saying when I don't look at the moon, it's not there?" So, yeah, I think they're really above themselves when they come up with these explanations, But
Yeah, it's impossible to prove or disprove, right? Because you're having to look at it to see it. It's kind of like that part of scientism or like magic or whatever you would want, sorcery, right? It just makes you question everything. And but to me, that they're even pointing towards the supernatural, right? Like, which even points more towards a supernatural God, because that's what God would be. It would be something above nature, above natural, above man, right? Supernatural.
Well, that would definitely be supernatural if a particle behaves a certain way when you look at it and another way when you don't. So,
Yeah,
yeah.
yeah, it would. But it's pretty difficult to prove or disprove, right? It's just a theory that you can't dispute. So they claim it as their own, right? There's huge funding, right? Even local universities, like not state universities, but even smaller universities are getting these huge funding projects, right? Just do with it what you will. Just we want to promote it. We want to, look into it. We want to do this, and whoever can come up with whatever, you know, here's some money, right? And write a paper on it. I think the more they get it out there and promote it, they can say, look, it must be true. But they fund it. Of course, people are going to do it. You give me money to print something and research something, I'm going to do it, even if I don't believe in it.
Yeah, at this point, it's just like you said, they get money, they have to write a certain amount of papers or they won't be considered relevant. And at this point, it's all a sham. It's like the peer review process and all that. Like, they don't do science anymore, they just do math, write
Well,
papers and yeah.
I think the peer review is a good system. I think it's just being abused.
Yeah, exactly. Yeah. You want to have honest peer review, but if the peer reviewers are contingent on if they approve your paper, they're going to lose their funding. Well, what do you think they're going to do?
Yeah,
They're
they deny
definitely
it.
going to, yeah.
100%. Yep, being abused. Money is the key to all of that, to a certain extent. I mean, they let things slide because they know it ain't going to take root, right? When some Joe Blow interim, scientific, a physicist that's, you know, not well known and is not going to gain any traction by what he's writing, they probably just, push it through or let it go. But these mainstream things, they control it like it's yesterday's news. They suppress it, fire people. This ain't, this isn't conspiracy theorists. This is conspiracy fact. You don't go along to get along. You're losing your funding. You're getting fired. You're getting demoted or not getting promoted. Whatever they want to do. Craziness.
Yep. And the thing is, most people either don't take time to research this or they just automatically believe, like spooky action at a distance. And they believe in contradictions, right? Like you can have two particles, you can split one particle in half, right? Superposition them, right? Send one across the universe, billions of miles away, right? Faster than the speed of light, can uh, transfer information, and then at the same time, they tell you, well, one knows what the other one does instantly, like contradicting. And you have some of these, I won't call them bozos, right? But some of these people that don't use their brain and say, oh, yeah, that's possible. Sure. It's not transferring information. What do you mean? How does one know what the other one did? See, they just accept without using critical thinking. So, I mean, it is what it is.
Yo, just came in 2 seconds ago. Entanglement, cool. So when people say it's not transferring information, that's specific to saying it's not a telephone line. Like, okay, maybe the particles are transferring information between each other, but you can't load a message into one side that comes out the other side. That's the limitation.
Yeah, but it's still a contradiction. You just said it yourself. Maybe they are because if you're to be honest with yourself, there is no way one can know what the other one is doing without an information transfer, right?
Sure.
Okay, so
yeah.
I mean, it's a contradiction.
Yeah. I mean, this. Look, people talk about it. Like, this is not a settled issue. People debate the interpretation of this. This is an open question as to whether or not this is or is not in conflict with the rule that nothing can go faster than light. And I think it hinges a lot on like what interpretation someone takes to what the speed of light restriction is all about. If you take a really strict interpretation of it and say that like you can't send a message faster than light, then entanglement doesn't seem to provide any way of doing that, right? Like, so even
Yeah.
if something's going back and forth between the particles, like I, the human being on one end, can't load a message into it that someone could read off on the other end. So, but look, people debate this. This is an open thing that is contentious in physics.
Well, I'm glad that you said that, right? But didn't somebody win a Nobel Prize a few years back? Because
Yeah.
they. So I mean, to them, how debated is it if they gave somebody a Nobel Prize?
I mean, the Nobel Prize was important. I mean, that was basically confirming that entanglement's real because there was this concept of the hidden variables, the idea that the particles like already knew what they were going to do ahead of time, and so the idea was like this. So like imagine you have two like gloves, a left glove and a right glove, and you put them in two envelopes and mail those envelopes to other sides of the world, and someone opens an envelope on one side and is like, ah, this is the left glove. Now you immediately know that the other one is the right glove. So there was an idea that that's what could be going on, that you wouldn't need the two of them communicating what they're going to do because they would have had a shared plan all along from back to whenever they had at some point in the past been in contact. And that got ruled out. And that was the big deal. And that was what the Nobel Prize was over, was ruling out the idea of hidden information they'd had all along. So it does force the issue of what is happening when they do something and the other one does the opposite thing instantly at a great distance. Yeah.
Okay, so how are you distinguishing? So I mean, first you did agree with me, right, that it's not possible for one
That what's
to
not
know what the other one is doing without violating the speed of light, correct?
Yeah, I guess it's I guess it comes down to what you mean by violating the speed of light, but yeah, I mean I think that my interpretation of it is that um they didn't the particles did not already have a plan as to what they were going to do. You have these two particles, you separate them out, and then one of them, let's say, spins one way, and instantly the other one is spinning the other way. So this does seem to be a instantaneous connection between the two of them. Yeah.
Right. So wouldn't that be violating if it's further than the distance that the
Yeah.
speed of light information can tell one what the other one's doing? Wouldn't that violate the theory?
Um so so the idea is that there's these specific paradoxes that could arise in relativity if you could send a message faster than light. And even though the particles seem to be interconnected in a way that one of them is affecting the other instantly, it's also in terms of random behavior of the two of them. This is the key point. So you've got the two particles, and one of them randomly starts spinning one way, and the other instantly starts spinning the other way. But what we can't do is manually make one spin one way to cause the other one to spin the other way. So even though they're connected, the thing that they're connected over is still what seems like random behavior. Connected random behavior, but not something that you could like take the particle and twist it one way to like type out a message that then makes the other one instantly go the other way. So that's the nuance there. That even if they are connected in a way that's breaking the speed of light, it's only in regards to this uncontrolled random behavior they have from our perspective. So we
Right, I
can't
get
tell
that.
them.
That's
Yeah.
the excuse they use, like the free get out of jail card, right? But
Yeah, I mean,
irrespective, hold on,
yeah.
let me finish. If irrespective if you can send a message or not, the fact of the matter is one knows what the other one just did instantly. So there has to be some sort of communication. Whether you can send a message or not is another issue, right? But
Yeah.
there's no way that you can make an argument that one knows what the other one is doing instantly without it being communicated, in my mind.
Yeah, I think I agree with you philosophically. And maybe you could then say, yeah, I don't know. I do think I do think it's a philosophical issue for relativity, but on a more sort of technical level, no one has found a way of using it to build a type of instant telephone that would immediately create like catastrophic paradoxes. Like we're right at the edge of it, but we seem to be being just saved from like having a catastrophic paradox that would like affect us in the real world because you can't load a message into it. But philosophically, I do agree with you that this does seem to say that the idea that nothing could go faster than light is just incorrect here if this entanglement phenomenon is real.
Right. Thank you for agreeing with
Yeah.
that. Like,
Yeah.
and another thing is like, is there any way that they have tested this? Think about it. Was anybody at a distance further than the speed of light can communicate to verify this? No, this has not been verified. This is all theoretical at best, and using that word loosely, not scientifically. Right? Would you agree with
Well,
that?
what they do is they separate the two particles to two different locations, and then in this really delicate way, and then they agree that two different people will each like check which way the particles are spinning to confirm that they're spinning in opposite directions of each other. You know, to confirm that what one of them is doing in one place is the opposite of what the other one is doing in a different place. Yeah, so it's like that's what's actually being seen experimentally.
Okay, I get. Oh, I just read what John wrote. So John, Einstein was wrong. Whoa, be careful now. The smartest
Einstein.
man in the world was wrong?
Yeah, science is a work in progress. I don't believe in deifying anyone.
No, I just like to jab people that are so sure of their cosmology, right? And they always back up Einstein. And when we say, well, he could have been wrong, they go crazy. But here he is. Einstein, just like SC, Einstein was wrong. How sure are you of that, John? Are you saying you're smarter than the smartest man in the world, John? It doesn't sound good when someone says it to you, huh? Because they always tell me that when I like, you know, question a theory. Oh, you think you're smarter than Einstein, eh? Yeah, see? Yeah.
Uh, I totally agree that this kind of cult around Einstein is a huge problem, and the way people have treated him has been a major issue. And I say that as someone who respects many of the things that he did, but I think that the deification, you know, of him after his death
Yeah,
has been a major
exactly.
problem. Yeah.
Yeah, like this man could be no wrong. Like he's like God, right? Like, no, sorry. It's just like
No,
No
every
one
other
talks
man.
about him like that.
no, people do treat him that way, and it's a problem. And even professionals will get really touchy and like, oh, you know, you think you're smart enough, you know, to contradict something Einstein said, but that's not how science should be. You know, science, like every person's just a human being. Like no one, you know, even a really smart scientist is still just a person.
Yeah, like I mean, yeah, I think we should like don't take all this too seriously, right? And have them up in pedestals, right? Because they're just men. They're fallible just like you and I, you know. So I mean, yeah, I mean, so what if Einstein said something? Could be wrong. Einstein said that you can take space and time and make it into a fabric. I mean, I think that's the silliest, dumbest thing I've ever heard in my life, right? with absolutely no evidence, but it's the theory of the day. It's God, it's gospel. You cannot question that.
Fabric is colorful language, to be fair.
Yeah.
We didn't literally mean there was a blanket out there in space.
You honestly believe, like, I'm not putting you on the spot, but you honestly believe that you can take time, which I believe is a concept, and what's between me and you, and make it a fabric that is gravity? Like, does that really make sense to you? Like, I'm not trying to put you down, but I'm just because you're a logical guy, and I think you're very fair, right? I mean, do you actually think that's a possibility?
Yeah, let me steelman this and give it a different way of thinking about it, right? So like um let's just start with space, right? So we use a coordinate system, to talk about space, a grid of lines. And it might seem most natural for the grid to be the same everywhere, like only straight lines evenly spaced. But like you could draw the grid any way you want. It is just kind of imaginary lines for how to talk about places and distances and stuff like that. But we do have a sense that some grids would be more natural than others. There's a reason why we defaulted for hundreds of years to drawing the coordinate grid of space in the very straight line way that we did. And it's because Newton's law, an object in motion remains in motion. We perceive objects as moving in straight lines, so it makes sense to say that they're following the natural grid lines of space. And one of the main things that Einstein pointed out is that because everything falls at the same rate in a vacuum and seems to fall along curved paths, what if you took those as your default lines of space? So I really interpret it as basically saying that we can choose to overlay onto space a curved grid, and we would want to do that because it better matches how objects are actually perceived to move. Right. So rather than drawing a straight line grid onto space and then having objects follow paths that look curved on that grid, if you drew a grid that was already curved, then you could have objects that are falling already be naturally following the grid lines that you've drawn there. So that's maybe a more reserved way of thinking about it.
Well, I see what you're saying, but that would be another contradiction, right? Things in motion will continue in motion in a straight line unless acted upon by a force, right? And then right after, well, it's a curving space. You see, that's another contradiction. Like, I can't help but not see these contradictions. You know what I'm saying? I guess that's the way I think. That, I mean, you can't have it both ways. Is it traveling in a straight line until a force acts upon it, or is the space curved and it will curve? I mean, that's a contradiction.
I'm trying to think what you're saying is the contradiction here. Well, this was how Einstein was trying to say that gravity. This is what he meant when he was saying that gravity isn't a force, because what he was saying was instead of the Newtonian idea of an object moves on a straight line until a force acts on it, Einstein reframed it to an object follows the natural lines of space until a force acts on it. So gravity then isn't an object being pushed off of the natural grid lines of space, but is just following them if they're curved into an object. That was the conceptualization Einstein brought to it. And I don't know, I mean, maybe that's not the right conceptualization of things.
Yeah.
But I mean, people can criticize it by all means, the concept of it. But I do think in terms of objects, like I don't think about space and time as these pure abstractions. Like I think a spatial distance is a ruler stick, and a time amount is the tick of a physical object. And, if it makes sense to use a warped grid, it would be because physical objects are naturally kind of falling into line along curved paths. And if it makes sense to say that time is moving at a different speed somewhere, it would be because physical clocks are ticking slower if you put them in one place compared to another place. So I would always, want to bring this back to like not saying like, oh, space and time exist and then have this causal power to warp and change things about objects, but I would say like we know that physical objects exist and space and time are an abstraction from it. So if we're going to say time has slowed down, what that to me means is that actual physical clocks are ticking slower if you put them in a particular place. And then saying time is slower over there is just kind of like a way of summarizing that, a way of summarizing the idea that any clock you put in a particular place is going to tick slower over there than over here.
Oh, I'm so glad you said that, because that's an argument I use. And again, I hate to be like confrontational, right? But since we're talking about it, right?
Yeah.
This is like another argument I use when they talk about the twin paradox, right? Exactly what you said now. If time were to slow down, that would mean the clock would have to, slow down in its ticks, right?
Yeah.
Okay, so now we can talk about the twin paradox, right? Now, the story goes, right? And I'm not saying I believe this, I'm just repeating the story.
Yeah.
That you have one brother here on Earth, a twin brother, and they're of course the same age, and you send the other twin in a spaceship traveling near the speed of light, right? And one brother ages on Earth, and the one in the spaceship doesn't age, remains the same, right? Did I still mind it correctly?
No. I mean, well, the one on the spaceship ages not as much, comes back
Ages
younger.
slower, right?
Yeah, ages slower. Because of the
We can
motion.
put it in those terms as well, sure. Okay, so that would mean then that the brother on Earth, in order for him to age, that means the ticks on the clock would have to have sped up, right? Correct?
Well, no, it's the one in motion that's said to be slowing down. That his ticks are slowing down.
Yeah, but then his ticks are slowing down. So then, how does he come and find the brother on Earth older? Wouldn't it mean that his time would have to have sped up simultaneously? Because just because his slows down, right? That means the brother would have to have aged quicker in that allowed period of time, right? Because in 7 minutes, surely the brother on Earth couldn't have aged 80 years, because that would mean the clock would have to tick faster, and the Earth would have to speed up if we're to believe in the story of day and night. Does you understand what I'm saying?
I think you might be saying it backwards. So it's the if we take the tick rate of a clock on Earth as like the normal rate, then the person who's on Earth is having their time tick just the same as it always was. And it's then the person who's on the spaceship flying in a circle who's having the slower rate of time. So the one on the spaceship has way fewer ticks. Their ticks are much slower, much further apart. So it's if you say 80 years pass on Earth and only 7 years pass in the spaceship, that's attributed to what happened to the spaceship, not the Earth suddenly having time speed up, but the rate of things happening in the spaceship slowing down.
Okay, I get how you're looking at it, right? But zoom out and think about this for a second, right? Because the time that the brother on the spaceship is like 7 minutes or something, 7 or 10 minutes, I forget what it is. So that's the allowed time, right?
No, but
7
that's the
minutes.
distorted time, right?
Yeah, but then
if we're
but how can the brother age quicker in 7 minutes? There has to be an absolute time, right? That the spaceship traveled. Yes or no?
Oh, yeah. I think honestly, the easiest way of thinking about it is to say that there's an absolute time, that the person on Earth is the one with the absolute time. The person on the spaceship is the one who is undergoing the distortion of time. They're the one who's slowed down. They're the one who's deviated from the baseline, not, the other way.
So you're saying that 80 years did pass on Earth, but
Yeah,
somehow the brother on the spaceship, time slowed down.
Yes, yeah, that's where I'm attributing it to. Yeah, it's the one in motion is the one who's having things work differently for them. They're the one who's different. They're the one who's experiencing a slower rate than the rest of the world.
I might give you that, but is there any way that we can prove this? Again, this is just another, um, another theoretical, and I use that word loosely, thing, right?
Well, I think the analogy is like if someone freezes and then wakes up later. Like you freeze someone, 100 years pass on Earth, and then you thaw them out of the ice, and they don't look any older. But it's the Earth was normal. It's they were the ones who were in stasis. So just as far as setting up, for whom did things go weird? I'd say it's the person on the spaceship flying around who's basically been put in an ice freezer, so to speak, of everything has their rate of aging and time and everything slowed down, while the Earth remained normal.
Okay, so let me ask you this then: if there was a God's eye view, like an observer from a third perspective, right? What would that person see? Like to him, to that person, would he be looking at the 80 years of the Earth,
Yeah,
or would he
yeah,
be
yeah.
looking at the 7 minutes? How would he see it? Because it's kind of perplexing.
I'd say the 80 years. Yeah.
He would be seeing the 80 years.
Not the 7 minutes. Yeah.
To me, look, I mean, it's very, very hard to believe such a thing, right? Because obviously there's nobody on the spaceship that did this to confirm it, right? So,
No, they did do the atomic clock fly around. The sensitive clock. There's a lot of things that have been tested with particles and stuff.
the cesium clock, yeah, we can get into that one. Like it was 10 billionths of a second slower, and I mean, really, I mean,
Yeah,
okay,
and I
like,
don't think anybody
yeah.
here has ever personally verified these observations.
And for that to have worked, right? Isn't it said that they cannot? And this is a good question here. I think, isn't it said that the reason there's only the two-way speed of light is because, and the answer to that is because they cannot synchronize the clocks? You're aware of that?
Well, I think it's that. How would you synchronize the clocks in two different locations without sending a signal? And then what's the signal delay? So it sort of becomes like a cyclic issue of like, if you're trying to measure the one-way speed of light, you need synchronized clocks in two different locations. But how do you check that the two clocks are synchronized without them communicating? And then how do you account for the latency in the
Exactly.
signal that
So
you're using to
how
communicate?
did they do it with the cesium clocks? How did they manage to synchronize one clock on a plane and the other one on the ground?
Well, they weren't trying to control to see if they were synchronized while in motion. It was the two were synchronized while both on the ground next to each other. And that's what they know. And then they put one on a plane, fly it around, and then bring it back. So it is more analogous to the two-way thing, because it's one thing went away and then came back.
No,
So
but
the
hold
only
on.
two,
The
yeah.
clocks, sorry to interrupt you, the clocks on the ground, they can synchronize them while they're not moving. There's no light traveling between them.
No,
So
that's
I mean,
what
how
I'm
is that
saying is that
analogous?
no, what I'm saying is that you had two clocks on the ground. They're synchronized while on the ground. Then you
Oh, well,
send
the
one of
same
the
would
clocks.
be with the light. The same would be with the two clocks that would measure the light. They're both on the ground. They're both not moving. So why can't they synchronize those?
Oh, well, you want to separate them, right? To measure the one-way speed of light.
Yeah, they're one is on one side of the room, one is on the other side of the room. They're both not moving. So why is the excuse? I'm asking. I don't know, right? Because it seems weird to me. Why can they not? Because the excuse is they cannot synchronize those two clocks to measure, right? So how and they're both not moving,
So
correct?
if you're going to synchronize them, they need to basically be in the same physical place. They need to basically be physically touching, right? If you've already moved them to opposite sides of the room, how can you check that they're still currently synchronized? Because now you've got the
The same
latency
way.
of any
Sorry, go ahead.
signal. Well, like one point would be like, if I've got a clock on the other side of the room and there's a wire running between them and I press a button on one of them that resets them both to 0, they're now not going to be synchronized because where I press the button on one of them, it immediately zeroes out, but then the signal has to go across the wire to get to the other one to zero out that one. So, like, when people synchronize things, they have them like physically touching as close as possible so that like you can know that the signal of reset to 00 on the clock is happening for both of them at once because they're like next to each other, as on top of each other.
Fair enough.
Yeah.
Fair enough. So then how did they do the ones on the plane? One was on the ground, right? And the other one that they took on the plane, they put it next to it and they synchronized it, right? Is that what you're claiming?
Well, they were synchronized before it was put on the plane. So
Well,
they
yeah,
were
the
both,
same as
yeah.
would be the clocks with the light. They'll synchronize them before they move them. They'll put them next to each other, synchronize them the
And then
same
you
way as the plane, and then they can move them across the room and do the test, right? Isn't it the same thing?
Yeah, except the issue if you synchronize two clocks when they're physically right next to each other, and now you've moved one to the other side of the room, how are you sure that they've remained synchronized?
Okay, can I
As you
not make the same argument then with the two clocks on the plane and one on the ground? Can I not make the same argument you just did?
Well, with the plane, they were expecting the clocks to end up different from each other because one of them had flown around in the plane. Sorry, can you repeat what the argument is?
Sure, maybe it's confusing.
Yeah.
You're
Yeah, maybe I
saying
missed
the
it.
reason that the clocks, the experiment on the time dilation on the plane,
Mhm.
you're saying that they were able to synchronize the clocks because they were right next to each other, correct?
On the ground, yeah,
On
before
the
one
ground.
was playing.
Okay,
Yes.
and then they took one synchronized, they moved one, and they brought it up by hand on the plane, and they set it up on the
Yep.
plane, and they did their experiment, correct?
And then they flew it around. Yeah, and then they brought it back.
Okay, now, can't they do the same thing with the two clocks that will measure the speed of light and get the one-way speed of light? Can't they do the same thing? Why is it different in that case?
So with this time dilation thing with the plane, the two clocks, right, they're synchronized before one goes on a plane, then it goes on the plane flies around, then the plane comes back, then they're brought back next to each other again, and then compared a second time. So both times that the clocks are compared against each other is while they're physically right next to each other, at before and after the whole plane flight thing. So then this question of measuring the one-way speed of light of, you shoot a light beam across the room, and you use two clocks, like one where you shoot out the light beam and then another one which receives the light beam. And if I'm understanding you, you're saying you synchronize the two clocks next to each other, then you move one of them to the other side of the room, then you fire your laser across the room and use the
Yes.
time on the one. Yeah, so that will give you a time, right? But then the question is this: how do you know that the clocks actually did remain synchronized as you moved one of them across the room? How do you know that the motion of one across the room didn't offset the two clocks?
Well, that's the
'Cause now
same. That's a good question, and I can ask you the same question. How did you know the one that you put on the plane did not lose synchronization? See
No,
what
well,
I'm
they
saying?
did, but they didn't compare that. They didn't do the comparison while it was on the plane. They only did the comparison when they brought it back. So the
Yeah, but
only
it
thing that
wasn't
they
accurate according to your thing. So it was off from the get-go. You see what I'm saying? So they couldn't be sure. Was it because they moved it, or was it because the plane traveled? I mean, I think I'm being clear on that one.
yeah, so they were off, right? Yeah, so the two were synchronized
Right. So
originally.
how did they know? Was it because they moved it from the ground to the plane, or was it because of time dilation? How could they be sure?
Well, time dilation's caused by motion. So they were looking for the two clocks. They were looking to see if when the two clocks came back together, if the amount that the clock that had been on the plane ride now was offset from the other one was like what the expected amount was based on how long it had been on the plane and how fast the plane was moving. Um, like causally, could there be a different reason that it could happen? Maybe, but that's what they were checking for. They were expecting that the motion of the clock that went on the plane and went on the ride would cause it to be now out of sync when the two clocks came back together at the end.
Yeah, of course they were expecting that. Obviously, yeah. But it was off by
But
1/10 billionth of a second or something. So my question is, how can they be certain? Oh, and by the way, John says that the clocks don't have to be next to each other in order for them to be synchronized.
I'm sure they do. But I'll have to see what he's saying about that. Um, Yeah, well, so when the two clocks were reunited, the amount that they were now different from each other, it was a small amount, but it was the amount that they had expected it to be because of the motion of the one on the plane ride. And the theoretical explanation of that is time dilation. So the theoretical reasoning is that the clock that's on the plane, because it's moving, is experiencing time dilation.
Right. I'm sure that's what the claim is, right? But I mean,
Yeah.
yeah, I think I caused some doubt there in the experiment. And
Well,
then there's all the conditions that had to be met. The cesium atoms had to be kept at because temperature greatly affects it, and there's so many variables. I mean, they literally just carried them up the stairs. Literally, just
yeah.
carried them up the stairs.
Yeah, so they had to think that they had insulated these things in the cold chambers they were in sufficiently that there was no other reason that the clocks would be offset from each other, that there was no other physical, mechanical fact of the jostling of them that might have disrupted their tick rate in order to
Exactly.
say that
Yeah.
the thing was attributed purely to the time. But I think that this is true for anything. I mean, I don't think that you ever know for sure that just because you've seen a result that the causal explanation is your original hypothesis, right? Like, um, because there could always be alternative explanations. Like, I think the best you could ever say is like here's what we did to try to control for other variables, and we saw a result that we were expecting to see under a given theory, but I don't think that you can ever say that you know for certain that there couldn't be a different explanation of the result, or that there couldn't be some other variable that caused the same effect that you didn't account for properly. And I feel like that's just kind of fundamentally part of how science is limited. And that's as most as it could ever say.
Right. Let's just say I'm not absolutely convinced by their by that experiment. You know.
By the cesium atom clock, yeah, that's fine.
Yeah. Yeah.
I mean, it's yeah. Um, yeah, it was one thing. It's and there's other things, there's other things people point to, things that align with the theory, but you don't have to think that that's conclusive. Let's see what someone was saying about the
Like to tell me that if you send one brother away for 7 minutes, he comes back, his brother is dead, the earth aged, 100 years. That's a tall order. And using the cesium clock as proof, I mean, to me, it doesn't cut it, but to each his own. I can just give you my objections and how I see it.
Oh, John said something about Einstein's synchronization of two distant clocks. I think the subtlety here is that's already under the assumption that the one-way speed of light is the same in both directions. That's already conditional on that assumption. I'll double
Yeah, but
check that.
you can't assume that. There's no way to know because it could have traveled 70% one way and 30 the other.
Yeah, that's the cyclic thing is that that the synchronization of two clocks in different places is dependent on knowing the one-way speed of light, and measuring the one-way speed of light is dependent on knowing the synchronization of two clocks in different places. So it's a bit of a catch-22 cyclic thing. And the only thing anyone agrees on is the two-way speed of light.
Yeah, exactly. Yeah.
Hey, zzpop.
Yeah.
So Whitson was in here yesterday. I was arguing with him, and he was using you. Since you had that discussion with him, he's using you to say that you claimed, which I don't think you did. So please correct me if I'm wrong, that the purpose of MOND is to supersede relativity.
General relativity. And maybe. There's subtleties here. So there's two theories of relativity. There's the special theory of relativity, which is what includes the idea that a moving object has a slower tick rate of its clock, time dilation, that its length is contracted, length contraction, and that's all just effects based on the motion of an object. And then there's general relativity, which is the theory that the gravitational field can be interpreted as the bending and warping of space-time and all that stuff. And MOND on its own isn't even a complete theory at all. It is really just a pattern in the data of how galaxies rotate, and it's sort of an idea that galactic rotation fits, a particularly simple equation. But that one simple equation, the MOND equation, isn't meant to be an entire new theory of everything, on its own. It's a starting point. It's a question of what type of theory of gravity would produce the behavior that we see in the MOND equation that seems to work well for galaxies. So the ideas of modified gravity, which sort of grow out of MOND as a starting point, do seek to supersede at least some of Einstein's general relativity. But that could mean a lot of different things. It can mean a lot of different things. And I definitely would not say that the purpose of MOND is to supersede something like that time dilation exists as you're moving, right? So it's the devil's going to be in the details here of what aspects. There's a lot to the theory of relativity, and any modified theory of gravity is going to supersede some of the bullet points of relativity, but it's not an all or nothing thing. And the vast majority of modified theories of gravity that I'm aware of still completely have within them things like time dilation, stuff like that a moving object experiences a slower rate of time. So I do think that there's a bit of a kind of linguistic confusion of that the theory of relativity means a lot of things, and it has these two major wings to it, the special theory of relativity and the general theory of relativity. And all I can say is that a modified theory of gravity is going to come into conflict with some number of bullet points under the theory of relativity somewhere down the line, right? And I can imagine people misinterpreted that as saying that a modified theory of gravity is completely throwing out everything we know about relativity. I didn't say that. I would never say that. That is not my claim, but I could imagine why someone might have misinterpreted me as saying that. There's a spectrum of features that exist within the theory of relativity, and which of those gets superseded by a new modified theory of gravity is going to depend on the specifics of that modified theory of gravity. So I definitely did not mean to in any way imply like an all or nothing thing of that a theory of MOND would a theory of modified gravity built off of MOND would necessarily mean that we have to go all the way back to the drawing board and even throw out something like time dilation or something like that.
Well, forget about time dilation.
Yeah.
What about just localized bending of, maybe not on a, because you still have to explain Einstein rings and things like that, right? As to how that's being created. Like if space-time is not bending, what's the explanation for that, right?
Oh, no, to be clear, a lot of modified theories of gravity are still in the framework of what we would call bending and warping of space-time. The dynamics might be a bit different, but conceptually, these theories still completely lend themselves to those pictures of the grid of space-time warping in towards a planet or star. It's just that the formulas for exactly how that happens are changed. There are some people who are working on things that are an even more radical departure than that, right? So, like, the field is very open to different interpretations of things. But, so for clarity here, if you are working on a modified theory of gravity, it could be one that still is within the paradigm where gravity is described as the curvature of space-time. You've just changed how that happens. Or it could be something more radical than that, where it's a different paradigm. So it's hard to make a singular general statement about what all theories of modified gravity have in common with each other. I personally find the image of the warping of space-time totally fine, and I've explained why I find it fine, and I don't have any personal interest in throwing that out, as I've made this point here that we are free to draw coordinate systems in whatever way we want, and it makes sense to me to draw coordinate systems that naturally fit the motions of objects, and because, as far as we can tell, all objects fall at the same acceleration in a vacuum, warping the grid of space to reflect that makes sense to me as a way of thinking about it. So modified theories of gravity don't necessarily have to step away from general relativity in that regard. They certainly can. It's going to depend on what goes into the theory. I'm sorry, that wasn't the most helpful answer, but it probably would shed light on how when I said that a modified theory of gravity seeks to supersede general relativity, what the implications of that could be very different for very different people's theories of that could range everything from a totally new paradigm to the same paradigm of warping space-time, but just the amount of warping is tuned to be a bit different.
Okay, and that's pretty much what I thought that you were saying.
Yeah, so I probably could have made it clearer what I said there, because people latch on to different implications.
Using your name to say that basically you're saying that you and other scientists like you are looking to throw out relativity and replace it because the whole idea of bending and warping of space-time is wrong.
I never said that I had an issue with the bending and warping of space-time at any point in my conversation with Whitsitt. And that is him editorializing something because of probably the thing that he has the biggest issue with within the theory of relativity, and because I was saying that I'm looking at alternatives to general relativity. And one of the issues is that the phrase general relativity to some people means a very specific set of equations that Einstein developed, and to other people means a much broader framework of any theory in which you have a geometrical interpretation of gravity as the warping of a space-time manifold. And unfortunately, even amongst professional physicists, I run into conflict about this. where I have tried to say to other professional physicists that, like, oh, have you checked out this modified theory of gravity? It's a different type of general relativity. And they've retorted back, no, no, no. Anything other than Einstein's original equations, you can't call that general relativity at all. And I found that very annoying. So, like, honestly, linguistically, I think there is a lot of confusion here. And I definitely should have, in retrospect, when I said that I am interested in alternative theories that would supersede general relativity, clarified that while I do have issues with general relativity, that is not the same thing as saying that I think we necessarily need to wipe the slate clean on even the concept of interpreting space-time as something that can geometrically warp. So I will clarify that to Witze next time I talk to him about it, that it wasn't an all or nothing thing that way.
So ZZ, good talk. I have to break for supper, so it was a good talk. I hope we can continue it at another time.
Of course. Let me also just throw one more wrench into all of this. Despite this visualization of the bending of warping being how general relativity has been presented to the public, even that is technically just an interpretation of it. That is, even if we're talking about Einstein's original equations as he wrote them down, there are to this day some physicists who believe in the experimental accuracy of those equations, but do not like or do not find helpful the visualization of the warping of space-time. Because that's fundamentally what it is, right? It's a graphic, it's an animation. It's an animation that's meant to, for some people, help them build a better intuition for what's going on. But you can find textbooks on general relativity which will claim that the geometrical depiction of general relativity is an analogy. And then you'll find others who say that it's literally the truth. And this is where things get really murky on the philosophical interpretive.
But isn't the whole reason why we get things like Einstein rings and gravitational lensing because the light is actually traveling across a warped space-time?
I mean, like, if you look at what a physicist is doing, they're computing a path that light will take, and they've got a formula that helps them compute it. And it's historically the case that as Einstein worked his way to the development of this formula, he developed a visualization that made intuitive sense for him, that guided him in the development of the formula, and that visualization is this whole deal about the bending and warping of space-time. I think though we could imagine like a simulation of this running on a computer that has no context for the concept that Einstein came up with about the bending and warping of space-time, for which at the end of the day it's just a number crunching exercise, right? You know, where here's a mass, here's a formula for what the path of a light beam will look like around the mass, you crunch your way to the end result as just like an algorithm. And that's sort of the shut up and calculate philosophy. So I like the interpretation. I definitely like the visual. I find the visual helpful. I find, when properly explained, the visual of the bending and warping of space-time does contextualize and make it more intuitively easy to understand and explain what is being described by Einstein's equation. But there is an attitude that says that any equation is just an algorithm, right? It's just a series of instructions for moving numbers around on a piece of paper, and we shouldn't get too hung up on anybody's interpretation of it. And because Einstein presented this formula to the world with a story and with a picture diagram representation of what he thought the equation meant, those two ideas got cemented together. So yeah. So there's a couple things going on. One of which is you know, is this visualization of gravity as the bending of warping in space-time the only way that someone could interpret the meaning of Einstein's equation? Technically not. Is it a useful way to interpret the meaning of his equation? I would say so. And then when you move to modified theories of gravity, which are different equations, now you could ask about those equations. Are they also equations that lend themselves to this visualization of the bending and warping of space-time?
So why is MOND called then for Newtonian dynamics and not like general relativity or Einsteinian dynamics? Like why is it called MOND instead of modified?
Right. Yeah. No. This is a great question.
Lager or something, right?
Yeah. So right. So Einstein's general relativity, his formula, along with this whole conceptual visualization that, may or may not be helpful, reproduces Newton's acceleration law, right? Like when you get down to a planet of a moderate amount of mass in the formula for general relativity, you get right back to objects fall to the ground at the rate that Newton predicted. It matches Newton. So MOND isn't a replacement of general relativity. It's a replacement of Newton. Like the information and the complexity of the MOND formula is at the level of Newton, not at the level of Einstein. So I feel like I need like a two-dimensional axis, sort of like imagine four quadrants. Okay, and in the lower left we've got Newton, and in the upper left we've got general relativity, and in the lower right we have MOND. Like MOND is it's like a horizontal replacement of Newton's thoughts of, like, in the era of Newton someone could have come along and proposed this as an alternative force principle against Newtonian gravity. What's needed is what would go in the upper right quadrant of that force square. That is to say, a full theory of gravity on par with what Einstein's general relativity can do, but one that results in the MOND acceleration rather than the Newtonian acceleration. So MOND is only a replacement to Newton. It's not a replacement to Einstein. And the idea is to take MOND as a starting point and then develop some sort of full theory of gravity that would give you back MOND in the same way that general relativity reproduces things falling in the way Newton thought things fell, but which would be a full replacement to general relativity. See if I can sketch out. So I hope that visual.
Like, even within our solar system, the Newtonian equations do break down when you try to do calculations like near the sun, for example. Like the Messenger spacecraft that they orbited around Mercury, the burn calculations had to be modified from traditional Newtonian rocket, calculations, because they were deep enough into the sun's well that that it was not producing as accurate a result as taking into account relativity.
Yep. So there's places in the solar system where there's these different limits, right, where you get outside the range of Newton's equations, right? So Newton's equations work within a certain range of distances and speeds, and when you get to Mercury, where you're that close to the sun and going that quickly, now Newton's equations break down, and you have to go to all of general relativity. And then MOND would be a deviation from Newton, really on the other extreme. So whereas Newton gives way to Einstein's general relativity for close distances and fast speeds, if MOND is a replacement to Newton, it would kick in at large distances and slow speeds. So, like, stars orbiting at the edge of the galaxy. But MOND still wouldn't cover everything. So that's why you need a full theory of modified gravity to hit that, like, missing gap outside of, you know, that's like MOND would only be good for long distances and slow speeds. If you wanted to go to long distances and fast speeds or something like that, then you would need to go to some theory of modified gravity that would be on the same level as general relativity. That would be a proper replacement for it. See if I can make a little diagram quickly.
Now, why are you yourself uncomfortable with the idea that gravity is nothing more than buoyancy and density?
Why am I personally? I don't.
Like to consider that a reasonable assessment of what gravity is just buoyancy and density.
Well, we can drop things in a vacuum chamber, and there's no buoyancy there, and there's no dependence on density there. So people will contest this, of course, I understand that, but I've seen the vacuum drop experiments myself, and the fact that objects fall at the same rate in a vacuum, irrespective of their density, and there's no buoyant force because there's no fluid around them, would make me think that the reason things fall is having to do with things fundamentally not connected to density and buoyancy.
Well, Whitson was trying to argue that it could be something related to electromagnetism.
Yeah, and then people bring that up.
And how do we know that it's not electromagnetism?
How do we know that gravity is not electromagnetism? Because our understanding of electromagnetism is that the electric force will push a positive charge one way and pull a negative charge the other way. But when we drop things, they all fall, regardless of whether or not they're positive or negative. So that doesn't align with the electric force. The electric force does different things. It pushes positives and negatives in opposite directions, but every single thing falls. So, there we go. Like there's a smarter take someone could make to it, which would be like, oh, within a unified theory of everything, gravity and electromagnetism might be merged together into some more complete understanding of a singular unified force that does everything. And like, I feel like that would be the more nuanced take to it. But if someone's literally saying that the reason something falls is because an electric force is pulling charged objects to the ground, then why are oppositely charged objects not flying up into the air? And I've never heard anyone really explain that.
Yeah, maybe it's a combination of a few things, especially when it comes to density. But yeah, great point.
Again, objects of different densities fall at the same rate in a vacuum chamber, right? Like, so obviously density and buoyancy are variables that play a huge role as to how objects fall in a fluid, but if you remove the fluid, if you do it in a vacuum chamber, then there's no buoyant force, and then everything falls at the same rate, regardless of its density. So.
Oh yeah. I was just thinking how dense objects don't really spontaneously rise unless they have some sort of help. You know what I mean? But yeah.
And people talk about they're like, oh well, you could turn off gravity by levitating something with magnets, but that's not turning off gravity. That's just balancing one force with another.
Yeah. Right. Introducing some sort of force, perhaps even, or yeah.
I'm just
But yeah, either way, even the globe, even if you're taking the position of the globe universe model, there's a lot of opportunity still for science for the new textbooks in the future, right? Because there's still a lot of placeholders. So yeah, as people like you, ZZ, continue to push the cutting edge of research, yeah, new ideas are going to be presented and considered. Sure, it's exciting.
Yeah, I'm hoping for paradigm shakeups, whatever they are, just because that'd be cool. That'd be great. And I mean,
Yeah.
I've got my own ideas, but it's you know, to better. Yeah, I'm gonna post in a second a little graphic I'm making to try to get across the relationships between all these different terms of general relativity, Newtonian gravity, MOND, modified gravity. So I might just be quiet for a second as I finish writing this, and then I'll post it.
Exciting. Thank you. Weight is big business. We have to weigh things to ship them. We consider evidence, I guess, by weight, maybe metaphorically speaking. But yeah, weight is big business.
Why can't we be attracted to the Earth from underneath the ground? What's impossible about that? If at 300 miles down or something, and you've got liquid iron or at a state at 770 degrees Celsius, which makes it magnetic apparently. So if you've got the big magnetic force 300 miles below the ground, is that impossible?
That's a great question. I just posted something from the USGS website where it says the crust of the Earth does have permanent magnetization.
And I had a question about the vacuum chamber thing. Isn't that more directly related to the medium it's in and having less resistances than it is about the density at that point?
Well, that's something to consider. Yeah. Right, because we can pump out a lot of the material and potentially all of the medium. I don't know if all of the medium is actually evacuated in a vacuum chamber.
Well, I would say all or not is irrelevant if we can see it's having a clear effect on the drop rate of objects.
Yeah.
So I don't see how the vacuum chamber is a rebuttal to density being a cause of downward force.
Density being a cause of downward force due to.
Well,
I was talking
we
about
would
the
say
density of
gravity.
the object dropped.
What's that?
I could drop two different objects of very different densities, and they fall at the same rate.
They fall at the yeah, but what I'm saying is, isn't that an impact of removing the medium they're in rather than directly messing with their densities? Right? Because I think when people bring up density as a reason for falling or buoyancy going up, is directly tied to gravity, right? It's not just like a standalone thing as we understand density now. I don't think they usually use it that way. It's like intrinsically tied to the reason things come down. So in a vacuum, you would be impacting the medium, and that says nothing about what the density, why the density is bringing something down.
Great observation, Anchovy. Yeah, we've impacted one density potentially, right? But by removing the gases. But that's interesting. I've never thought about it like that. Thank you. I did post an infographic on what the ancient Greeks thought about density and buoyancy. Hopefully, it's accurate. I tried my best to get it that as accurate as possible.
I mean, density makes no sense because density is nothing more than the weight of an object compared to its volume, and that doesn't seem to have any impact on how fast it falls. And it also doesn't tell you any reason why it would have any preferred direction.
Well, they would say the same thing for gravity, right? They're just that's what I'm saying. They're intrinsically when they say density, right? They are intrinsically tying that to the phenomena that we would say gravity is doing. So when you remove air resistance or you remove buoyant forces around an object, you're not directly attacking the argument they're making. You're changing the medium that it's in, thus affecting why things fall down at the same rate.
Yeah, like dropping two objects in a pool. We just remove the water, and then it'll maybe fall differently or the same. We just change the medium that the objects are in and surrounded by.
I don't understand how this is a causal explanation. If you're saying the cause of something falling is that you remove the thing that stopped it from falling, that doesn't make sense to me as a causal explanation for why something falls.
Well, okay, this is how I've always understood it when someone brings up density as a reason for falling, right? Is that they're saying there's this phenomena of things coming downward, right? We call it gravity. They'll say, they're filling it in for density.
Mm-hmm.
I think what they're saying there is because we don't understand gravity, I think they're just using that interchangeably, right? So density is the cause, is the causal part of why it's coming downward for them. So when you put it in a vacuum chamber, I mean, obviously there's gaps here because this isn't like a thought out thing, but this is what I'm getting from them.
Yeah, well, and then it's not really the density of the object. I mean, if all objects of all different densities do fall at the same rate, then I'm not sure why.
Well, because the different this is so the density, having density in general is the downward effect, right? The difference in the density affects how well it can come through other resistances.
Well, yeah, I mean, but that's not controversial at all. Like once you've got resistances, then the density is how well it does pass through that. Like the more dense object falls better through air and water and everything. Like that's a totally straightforward and accurate statement about how objects sort themselves when falling through a fluid. And then we're saying, okay, so anything with some density is going to try to fall, or gas or whatever, is going to try to fall. But now, why?
Right. So if you remove those mediums, I mean, I would expect them to say that essentially, if there's nothing it needs to pass through, its drop down rate is now it's null. Nothing affects it. So now everything's even. Think of.
If you had a 10-pound object that was a sphere and a 1-pound object that's a sphere, so that they're both the same size, would they fall through a liquid medium at the same rate?
I don't think so. Let's say if you have one very, let's say like porous, and then one, or maybe not, both of them are not porous. One will be like a extremely dense metal, maybe enriched, so it's really heavy, and one would be on the far end, the other end of the spectrum. Would they fall at the same rate? I don't think so, but what are your thoughts? That would be a great test.
So if they're both the same size, so it's not the surface area of them that's causing the difference. That's a key.
Yeah.
You don't. So the